All right, I just wanted to record this part of the workshop because it didn't record very well. And so when we jumped into this part of the workshop, it was the doing part of the workshop. And so the first part was to make sure that everybody had the software on their machine. So the two softwares you'll need is the Arduino IDE, which I linked here in the slides. And so if you click there, you'll download the latest Arduino integrated development environment, which will allow us to see our code, and it looks like this. Okay, when you open up that IDE, they have one for Windows and Linux as well. The other software you'll need is the processing software. Another IDE actually to process serial input and make it into an image for our cameras. And so we'll need that IDE. So download those two and install them. And the processing software looks like this. We're going to open up these files in a second. The next thing that you'll need to do to get started here is these two libraries, which I'll go over. And then, of course, you'll need your BLE 33 Rev2 sensor and the camera. And using the edX kit, you can just plug them right in, and that hooks them all up. You don't have to do any other kind of wiring, which makes it awesome. And then you plug in your USB into the microcontroller, so like that. And then you can plug your USB into your computer. And I would do that first before you open your IDE, and usually your IDE will then see that device and install any necessary drivers that you might need. It's pretty friendly. So plug that in, and we can get going on the Hello World example that we'll do first here. And it's always a good idea to do Hello World to make sure that your device is working and to see the basics of a machine model. All right, so after you plug that in, open up your IDE. Now, you're not going to see this. When you open your IDE, you'll see a blank sketch because you haven't opened anything yet. And so the first thing you'll do if you have it plugged in is go ahead and make sure that it is seen by the IDE, your device, and you can hook that up right there. And then you can go over here to the libraries, and these are the libraries I was telling you to get in this slide here, which are the Arduino TF Lite by Terali, and it will install all the dependencies you need to run TensorFlow Lite, which is our machine learning language and, I guess, platform that we're using to create, this machine learning model on the device. And so you just kind of go over to your library manager. Remember, you push that little button, and you go to Arduino TF Lite, and you see that I've already installed it. You just have to install this one, and then it will install all of the other dependencies. And if you want to see all the dependencies that it installs, you can always go to, installed, and you can go down there and see this is for the camera. This one is for the TF Lite. And so it installs. And this is for that sensor, that 9 degrees of freedom sensor on the board, which is our accelerometer, magnetometer, gyroscope. And then the BLE, which is our Bluetooth on the board. All right, so you got that hooked up. Now, once you got those installed, you can go over here to File, Examples, and you should see the Arduino TF Lite examples as well as the BLE, and those other libraries that we installed all have examples with them. And during the workshop, we investigated this Hello World example. But remember that you can look at and run some of these other examples. They are well-written code with some great comments, and it will start getting you used to looking at some of this code. So the one I had everybody run was the Arduino TF Lite Hello World, which was a pretty nice Hello World example. Now, importantly, once you open up this sketch, you want to close your old sketch so that you don't have any conflicts in it talking to the BLE. So make sure again that the BLE is listed there, and now you can concentrate just on this. Now this code here is that example for Hello World. Remember that Hello World is the basics for a program or basics for a device to run, and this is the basics for a machine learning model to be created on the device. I encourage you, of course, to go through all of the comments and look at the code. To be honest, it is easy to read, nice, neat code. It's pretty simple because it is Hello World. Just noticed that they misindented that. Remember to unindent, it would be a shift tab. All right. So remember to compile it. You can hit the compile button even if you don't have a BLE. You can still install these libraries and compile it. And when you have the BLE hooked up, of course, you can compile it and run it with the upload button. So this button will compile it and run it. And you'll see your output here. I set my settings to show verbose output. So remember that you can always go to the Arduino IDE, go to settings, and then you can tell it verbose output somewhere here, right here, show verbose output, and so then you can see exactly what it's doing as it's working here in that output. Now, as we learned during the workshop, and if you know machine learning models, it does take a while for them to be created. So this compile is going to take a little while, which is a good lesson learned. And so you just kind of just let it work. As long as it's not failing, it is working, and we can close that and we can look at the next step as that's working. All right. The next step is to set up our processing software. Well, the next step is actually going to the next lesson we're going to do. Our next, I guess, activity we're going to do here. And so after we get Hello World to work, it will be great to go one step further and get the camera to work and upload a model to the machine learning device created by Google Teachable Machine. And so that was the next step in our workshop. And so that's why you needed that processing software. Okay. Now when we go to this next activity after that first one completes, we're going to use this tutorial here, which is a great tutorial. There are many tutorials online for the BLE sensors and the camera, but this one was recommended by Google Teachable Machine, and it does work well with the Google Teachable Machine. And as you can see in the pictures in this tutorial, it's a nice tutorial. I felt it was short, very direct, and it does work. And so you can move on to that tutorial. I always tell students there is one error that comes up, and so I put a link to how you fix that error here. This fix does fix the error when it does come up in the processing software, which is great because it's good for students to be able to debug a little bit. And as we can see, it is still compiling. So in the essence of time, I'm going to move on and move on to this guy. Okay, so you'll need the Arduino IDE again, which we already got, and it tells us that. It says that you'll need the processing software, which we already went over. It tells us that we need to set up the hardware, but lucky us, it's already hooked up. So, because we're using the edX board. Now we want to, okay, so now they're telling us that we can go to Google Teachable Machine. Okay, so you can open up the Google Teachable Machine, and I have one open there, I have another one open here, but let's just open up another one even. And so when you go to Google Teachable Machine, oops, I don't want to lose that though. I'm going to right click and open it in a new tab. It's a real fun kind of machine, and you can do a really simple image project, which I will share with you maybe in a different workshop, but well, sorry, the standard image model project is pretty easy to use. You don't even need any devices. But the one we're going to use for this activity is the embedded image model project. And you can click there. And when you get here, you can click on the device, and what you'll see is that you need these template sketches, one for the Arduino IDE and one for the processing IDE. And you can download these zip files here. I've already downloaded and opened them, but you download them and extract them, and inside of this one is an Arduino IDE sketch that you open, and inside of this one is a processing sketch that you open. And you don't want to open it until this is done, and finally my Hello World is done. So when the Hello World finally finishes compiling, you can then go to your serial monitor here, because that's what the code is telling us to do, and there should be some serial output here. If there is not, for whatever reason, actually let's make sure that it uploaded all the way. I'm going to go ahead and hit the reset button on the Arduino IDE just to see. Oh, there it is. Okay, so sometimes you have to hit the reset button, but you should see in your serial monitor this output message, which is our menu, and it says to enter a number between 0 and 6.28. So I'll enter 3, and it actually uses that machine model inference over here, or actually it created over here, and it uses that to determine the sign value of the number that you typed in. So it doesn't seem like much, but you can always, tell students, or if you're a student listening to this, it really is awesome. You're running a machine learning model. And remember that you can come over here to your model.h and you can see what a model looks like. Remember that your computer can only store ones and zeros. And so when we make these things, sometimes we think of them as these big clouds of intelligence, but they are just numbers. And so it's good to see your model.h here that was compiled already, created for us with another tool. This is why this is a Hello World, because we already have the model set up for us. And then we're using that model to make an inference and make machine learning inference so that we can do this calculation. And you can run it several times. You can run it with extreme values, and you can see that it does actually find that sign. So it's not calculating the sign, it is finding it with the machine learning inference that it created. Okay, so going back to the other activity though, so now you're ready to do this activity all the way. You download those 2 sketches, you unzipped them, and then you're going to open them. And I already opened mine, so I'm going to go to Open Recent, and this is the one that you'll see when you open. Now remember to close your other one once you open it. And I'm just not going to save it because I already have them saved. Okay, but you guys, of course, save it. So it says it's not connected, probably because I had the other one open, so make sure to, open this one. It's fine. All right, so this one here is the one that came from Google Teachable Machine, and what it does is this is a sketch that will connect to the camera, grab that camera input from the camera, and then write that output as serial output to the processing software. And it set up those connections over here in the setup function, and it's a pretty simple program. Okay, so it's kind of nice, and you can see that there's some code encapsulated over here that they can look at. Nice, neat, well-commented code that it uses. Now to upload this, of course, you hit that little button. It will erase the old Hello World program, remember. You can always run it again by opening up that old program and uploading it again. But it uploads this new program, which will talk to the processing software. Sometimes it does that, but if you hit it again, it should find the device and upload it. Okay, so I'm glad it did that, because a lot of times that does happen. So if you see any red output, hit upload again. Sometimes you have to close it and reopen it too. So I'm going to go ahead and close my Arduino IDE, and then reopen the Arduino IDE with that one program already connected. And I think it will be happier now. We'll just make sure. So always look down here at the bottom on the IDEs, and if it's working, just kind of let it do its work there. So as it's doing its work here, we'll let this sit here, and then we'll have to remember to upload it. The next part of the tutorial you'll see is getting the sketch into the processing software. So remember that you can look at that tutorial there, and you'll see that that's that next step here. Okay? All right, remember that you can get that processing software from that tutorial, or here it's the same processing software. And when you open that processing sketch, you'll see this sketch here, and you can read those comments again. And what it's doing, it's taking that serial input from the camera, and then it's piping it into a feed that Teachable Machine, a WebSocket, Teachable Machine can connect to, and so it can feed that serial input to Teachable Machine. And so we're going to run this after we run this one. So we're going to run this on the Arduino first, and it looks like it's fine now. Like I said, sometimes you have to restart the software to reset that connection. Okay, so once the software is on the Arduino, we can then run the processing software, which will connect to that IDE software. So it connected right away there. And so then you'll pull this down and you'll pick your USB modem there. It might take a second to connect. But once it connects, actually, I forgot to do one step with you. Mine was already working, but the step that might not work for you is opening that software, because you need one more library. Now the one more library, you'll get an error, and you can go to Stack Overflow and see that this person also got this error and how they fixed it. And what you'll have to do is you'll have to download this library that you need in zip form, and then you'll go over to your processing software, and you can drag that zipped file, the JAX-B, you drag it over to here, and it will add it to the library. Now one step that I didn't do in the tutorial that I forgot to do was that you go over to processing software, you go to Sketch, Import Library, Manage Libraries, and then you do have to look for the JAX-B. Actually, it's not called JAX-B though. What is it called? Oh yeah, so you drag the jar file, drag the jar file on top of your sketch. I don't know if I did that right in this tutorial. But note that you drag your jar file over the sketch, and it should fix the error. Okay. Let me know if it doesn't, and we'll get it working. But yeah, once you get it running, you'll hit that modem, and then you should see it pop up. I'm going to go ahead and hit reset on the Arduino, and so we'll see if that will fix the processing software here. I'll go ahead and hit stop and then run again on this software, and port busy. Oh, doy. I totally forgot. Once you upload that to the Arduino, you do have to close the IDE, importantly. Okay, silly me, I'm trying to rush here and I forgot that. So close that, because only one software can connect to that device at a time, the BLE. So now when we hit run, okay, so now I'm getting that error. So if I hit open recent, So now I'm going to try this. Oh, wait, we needed the jar file, which and now I am getting stuck. I know that I did fix it, and now I didn't write down proper. Okay, so I think it's just that. Oh yeah, one file added to the sketch. Okay, so we are actually back where we were, and so if I go to import library, and let me get the file that was open. Oh, okay, so I am getting stuck right now, but I will continue this video in 2 seconds after I get unstuck. All right, so let me go ahead and pause the recording. All right. So I was just gonna fix this up here. So the jackxb-api.jar file is the file that you need, and so you can search for that as well. But it is located in the download, so it's in that jaxb folder, in the mod folder, and in that mod folder you'll find the jar. And so I'm going to go ahead and open up my processing then and drag that jaxb file over to there. And it did say that it added it, and now it does seem to be working. And so, oops. Once it's connected, then you can see that I'm facing my camera, and you can see that black and white output from the camera. There I am. All right, and so now you can move on in the tutorial, and in that tutorial you are now up to this part where you can collect your data with the Google Teachable machine. So now you'll open up your Teachable machine and you'll attempt to connect to your device, and it should connect. Once you do that, you will need some items that you want to use for your machine learning algorithm, which I chose pumpkins and apples. So I tried to do something that I had around my house, and so the pumpkins and apples, I would set this, this camera up, and so that you don't have to move it a lot. So setting it up, I'll let you guys work on that. And what you do is you set it up so that it faces the apple about a foot away. And sometimes you have to wait a little bit for it to come in, and using a nice bright light and then also a background will also help make the apple come out a little bit nicer, and so that it just gets the picture of the apple and it's not confused with the background. And in this part of the lesson, if we were to make this a lesson, you could tell the students about some good usable data. It's a little bit hard because the camera does have that lag. And so after you get it to work, you would then, oops, my arm's getting in the way. Just gonna leave this shift here. But now you would hold down that button there to record the picture of the apple. So get the apple in there. And so you kind of want to, and you can do more than one picture of the apples. So this is where having a programming partner comes in handy. because now you can hold down and get some pictures of that apple. You'll want to tell the students, and then you'll want to do this, is turn the apple, maybe use multiple apples, and the more data you have, the better the machine learning model will be. We're just going to leave it like that. So I'm going to record some more pictures of my apple here. And so I'm holding it down. Remember that it is sending that serial input from the camera to the BLE. The BLE is connecting to the processing software, and the processing software is connecting to the Google Teachable machine and allowing me to input this data via the camera. Okay, so once you get some good pictures of your apple, you can then come up to here and you can name it. And then you'll want to do the same for your pumpkin or whatever you want to use. Remember that you can do more than 2 classes, but you need to have at least 2. And so here is the pumpkin. So when we do our pumpkin pictures, I had to back up a little bit more. And I'm kind of doing this on the fly. So, all right, you guys can get a little bit better at that. All right. So remember that you'll close this one here, and then you'll go to this device, and you can connect again. And here's where you'll want to take your pumpkin pictures. And so if you could get a little bit better picture of the pumpkin. And it does have that lag. So you'll come over here and you can record those pictures. Okay, you'll turn your pumpkin. You can use multiple pumpkins, remember. I'm just kind of doing this fast. Now, the more pictures and data you have, the better the training model will be. Okay, so after you get your images in there, now you can hit the training, and you don't switch tabs. Now you can see the output of your model, and in the output of our model, if it were to see the pumpkin, it is saying with some accuracy that that is indeed a pumpkin. Because I don't have enough data in there, sometimes it gets it wrong and thinks it's an apple. And the same thing I can do with the apple. So I can move my apple over here. And when I do the picture of the apple, oh no, it thinks it's a pumpkin. So remember, if that happens, it's just probably because I didn't have enough, oh, they're thinking of an apple. So if I don't have enough images in there for it to determine, what an apple looks like, it has some trouble and gets mixed up. Okay, so if I can get that camera just right how the images were, you can see that it's more confident that it's an apple. All right, so we've done the tutorial parts up to this part here, and you can see that they ran their model. And then the last step is putting this model back onto the device so it can run without the Google Teachable machine. And in order to do that, you click on the Export Model button, TensorFlow Lite for microcontrollers, it's the micro TensorFlow, and then you download that model. So it's going to convert it for you. Actually, it minimizes it and compresses it so that it can run on the microcontroller. After it converts it, it'll download it, and within that file itself, there will be a sketch, and then you can open that sketch. And when you open that sketch, it is a template with your model already set up in it. And so remember to just have the one IDE open. You can read through, of course, the comments. Remember that you can look at those other files that it gave you. it's a good idea to open them as well. Oops. Don't do that. But you can open them with your favorite IDE and look at those CPP files as well. All right, so remember this is also C++ code. And then to get that to run on your device, you would hit this little button here, which is our compile and upload button. Oh, we do have to select your board again. Remember to stop the processing software so it does not connect to the processing software and only have the IDE open. And then when you click this button, mine is having a library. Oh, I might have to make sure that I have that library here. All right, so I'm having a library error, and I'm going to stop recording right now because this is just the last step. And if I do fix this step, I'll add it on to the end of this recording. But this should get you going for our TensorFlow Lite running a model on a microcontroller. All right, so I'm going to go ahead and stop recording. Thanks for listening.